So we are starting. Is it okay? Is it okay?
Yes, sir.
Yes, sir.
See, last day what we did? Last day we had discussed about mostly the introduction to dynamics, that is idealizations and how to use idealizations. Then we went into an introductory treatment or discussion of vector calculus, in which we define vector functions, how to represent vector functions by diagrams, definition of vector derivative, how to represent vector derivative by diagrams, and then derivative of an unit vector, which is important. And we said for any unit vector epsilon, if we want to differentiate it with respect to what? N. What was the variable for differentiation for vector derivative? We wanted to differentiate epsilon with respect to, say, u, the independent variable. Del d epsilon du is n d theta du, and it will be n will be perpendicular to the original unit vector, and at the same time we can say that it will be in the direction of increasing theta. Mostly then it becomes counterclockwise as theta is positive or increasing in the counterclockwise direction. With this, we are formally starting our discussion of kinematics of particles. See, kinematics of particles is divided into three categories: rectilinear motion, plane curvilinear motion, and space curvilinear motion. See, rectilinear motion you have studied in class 2 with sufficient depth, and we are not going to much give stress on it. And as we have mentioned in our last class, the quantities which are actually vectors can be treated as scalars in rectilinear motion. Well, the most general and therefore the most complicated of all motions will be space curvilinear motion. But we will restrict ourselves to plane curvilinear motion, because here we can introduce almost all the general concepts, and at the same time we do not make it unduly complicated. What do we mean by unduly complicated? To first start description of space curvilinear motion, you have to have visualization of something in 3D. We want to avoid in the first course. Second, well, an additional coordinate will appear. That is how it is going to become more complicated than curvilinear motion. And in some cases where additional coordinates do not appear, you will see the same coordinates will have very much generalized implications and meanings. So for the time being, we will neither go for simple rectilinear motion or for spatial motion. We will go to plane curvilinear motion, and from plane curvilinear motion, once we have understood it, we can quickly transfer to space curvilinear motion. Only thing is, in that case, some complications will arise. But in the present course here, we will restrict to plane curvilinear motion only. Only if time permits, we will go to space curvilinear motion. Is this okay? So this portion of the notes is giving you the preview of our study. Why are we studying plane curvilinear motion, and what are the complications of space curvilinear motion? This we will clarify as and when we come to these cases. Now let us go to T9. Let us go to T9. Well, let us admit him. Is this visible? Can you see it clearly?
Yes, sir.
Okay.
Yes, sir.
Is the slide seen? Is the voice clear to all of you? Is
Yes,
it
sir.
okay?
Yes,
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 sir.
yes.
Right. Well, in this portion of the slide or notes, whatever you say, we will probably you are acquainted with all this. We will only, or if you so want, we will give some description of point 3 path coordinate S. Then we will give a little bit of importance here, and then at the end. Do you want a complete description, or these points which I have mentioned, which we have mentioned just now, we highlight? What is your choice? Do you require a recapitulation of the whole slide? Because probably you have covered in class 2. What do you want? Quick recapitulation?
Sir, yes,
Huh?
recapitulation will be fine. Sir, a quick recapitulation will be fine.
Okay. See, position vector. See, what is the position vector of A? The vector joining origin to the point. What is displacement? See, you know very well, where if the particle moves in this direction from the starting position from A to B, then the displacement from A to B is this. With reference to A, the displacement is this. Now, what is displacement then? Displacement, according to vector algebra, is change of position vector. And that you know very well. Now, what is distance? It is the length of the curved path covered. So, this length AB of the curved path is actual distance. And actual distance is either equal to or greater than the displacement. But just as displacement is change in position vector, is distance change of something? What is it then? Well, we write distance as delta S. What is this delta S? Is there something called S? Well, probably in your earlier classes you might not have fully studied it, because it is a concept of a little bit of advanced differential calculus. It says path length. See, by coordinate you mean xy coordinate, r theta coordinate, you know very well and will be using. Well, S is also a coordinate, because it is also a means of specifying a curve. This is called path coordinate. Path coordinate. So, change of S is distance. That is the mathematical way of representing distance. And the physical method is length of actual path traverse, which you know very well. See, quickly, recapitulation of velocity and speed. There are two types of it, average and instantaneous. You are acquainted with the definition of either. And when we take limit for delta t tending to 0, we give instantaneous quantities. So for speed, it is delta s by delta t, limit delta t tending to 0. So we call it dsdt. And this is a scalar quantity. Now, how to evaluate this expression? We divide by delta s and multiply by delta s. Now again go to our elements of vector calculus. See, when delta t tends to 0, b comes closer and closer to a. Delta r and delta s in magnitude, they approach each other. Divide delta r, divide magnitude of delta r by delta s, it will become unity. And in the limit delta t tending to 0, it will go along the tangent. So clearly it is ds dt into epsilon t, where epsilon t is the unit vector in the tangential direction. Now compare, easily it is the instantaneous speed into epsilon t. That is why we call magnitude of instantaneous velocity is instantaneous speed, but magnitude of average velocity is not average speed. See, now be cautious to distinguish these two quantities. They are different. You can very well understand. Now, clearly, what we have done earlier, see, if we are in this, we have done both of these cases we have done earlier. And I think you should not get confused that in circular motion, D will be perpendicular to R. According to this definition, R is constant in circular motion. In general motion, they have no condition or precondition. They will be arbitrarily directed. But one thing is very much clear from this presentation: velocity in whatever motion possible. We have shown here in plane curvilinear motion, in spatial curvilinear motion, it is equally true. The velocity is always along the tangential direction. Is this clear? And we go for a quick recapitulation here. Please understand this path coordinate. Please remember this expression which you are probably acquainted earlier, and you must be cautious about this. R and V are arbitrarily directed. That is, there is no specification of angle between R and V, but V is always tangential. Now let us go to T10. See, in T10 we go to acceleration, average and instantaneous. To start with, again, we will be giving importance to this red part a little bit. We will mention this, and then we will mention this. Others, I think we will quickly recapitulate. See, average acceleration is defined as this: change of velocity by change of time, and when you take limit, it becomes instantaneous acceleration. But just like if this be the analog of velocity, then the analog of speed should be here, but it's not there, because we have no term called delta v by delta t or dv by dt or rate of change of speed. There is no term for it. Do not start calling this acceleration. It will be wrong to call this acceleration, though off and on in colloquial terms. Oh, the speed is changing, the car is changing speed, it is accelerating. No, that is a colloquial term or colloquial application of acceleration. Acceleration means this quantity.
স্যার অডিওতে প্রবলেম হচ্ছে স্যার অনেক
অডিওতে প্রবলেম হচ্ছে।
হ্যাঁ স্যার অনেকজনের হচ্ছে স্যার। চ্যাট বক্সটা দেখুন স্যার, অনেকে লিখেছে।
চ্যাট বক্স আর মধ্যখানে দেখি কি করে বাবা?
স্যার ওই যে 42 এর পাশে যেটা আছে স্যার।
কোনটা?
এই যে 42 এর পাশে।
40 ও রোল 42।
হ্যাঁ স্যার ওই 42 এর পাশে যেটা লেখা আছে।
এখন একবার দেখো এবারে কি হচ্ছে। এখন হচ্ছে
না স্যার আমার তো হচ্ছে না, দাঁড়ান এদের বলি।
আর হচ্ছে জিজ্ঞেস করো। এই এখন কে ঢুকছে? ওই দেখো কেউ পাখা পাখা চলছে, ওইগুলোকে মিউট করতে হবে।
হ্যাঁ স্যার।
কারণ প্রবলেম হচ্ছে, দাঁড়াও দেখছি। ওকে নাও বললো তো, দাঁড়াও দেখছি চ্যাট বক্স। মি টু, অডিও ইজ ব্রেকিং সামটাইমস। তো কি করবে বলো, কি করতে চাও বলো?
স্যার এমনিতে স্যার আপনি যদি এমনিতে আপনি ক্লাসটা করেন স্যার, রেকর্ড তো হচ্ছে, তো রেকর্ডের যদি প্রবলেম তো ওরা রেকর্ডটা দেখে নেবে, ওটাতে ভয়েস কাটবে না।
কারণ আর তো আমার এখানে আমার হাতে কিছু নেই। আই ক্যানট ডু ইট।
আমারও স্যার আমার ওরকম পার্টিকুলার কোনো প্রবলেম হচ্ছে না, কিন্তু বাকিদের হচ্ছে, তাই স্যার একবার জানিয়ে দিলাম আপনাকে।
আচ্ছা, আর হচ্ছে দেখি, দাঁড়াও।
হ্যাঁ স্যার, স্যার সবাই বলছে ওকে, এখন ঠিক আছে স্যার।
ইয়েস, অডিও ইজ ব্রেকিং, রাতুল ঘোষ। ওকে নাও, ওকে।
হ্যাঁ স্যার, ওকে স্যার। স্যার আপনি কন্টিনিউ করুন।
ঠিক আছে, ঠিক আছে। So how much we told you? Oh, acceleration in strict definition is not rate of change of speed. Once again, be clear to distinguish these 2 points. But one point is, see, if acceleration is a vector and it is the derivative of velocity, then photograph of velocity, if you draw, acceleration will be tangential to it. But this is not a physical quantity. No one plots the hodograph of velocity. The hodograph of position vector is path a physical quantity, and therefore please understand, acceleration will never be or in curvilinear motion, it will never be tangential to the path. It can never be tangential to the path. It will be tangential to the hodograph of velocity, that much, nothing more. See, if v is constant and we move with that means we move with constant speed, what do we see? If it is not just a circle, if v is constant, then we call it a constant speed curvilinear motion. And in this constant speed curvilinear motion, the magnitude of v is constant. Therefore, acceleration will be perpendicular to it. So, acceleration for constant speed curvilinear motion will be perpendicular to velocity, and there is no need of the path being a perfect circle. This I think you have studied in your earlier classes as well. However, for the general case, acceleration and velocity are arbitrarily directed. One will not be perpendicular to the other. Now, what we try to do here is evaluate velocity and acceleration expressions in different coordinate systems, and we will be restricting to curvilinear motion as we have told in case of plane only. So plane curvilinear motion, and we will give some introduction to space curvilinear motion to show the complications. Okay. See, this we will quickly revise. There are for plane curvilinear coordinates plane curvilinear motion three types of coordinates: rectangular coordinate, path coordinate, and r theta or polar coordinate. Whereas if we go to space curvilinear motion, we will have rectangular coordinate, path coordinates. Polar coordinate will be called as cylindrical coordinate, and you have one addition coordinate, spherical coordinate. However, we will not be discussing spherical coordinate, only these coordinates which are required in plane curvilinear motion we will discuss, and we will give you some essence of the complications or the extensions required for space curvilinear motion. See, when do we use plane curvilinear motion? When x and y are independently generated or described, we use it as a case of evaluations or problem solutions using rectangular coordinates. This you have done in your +2 classes, so quickly we will make a revision. And the advantage of this coordinate is, since I and j are in fixed direction and they are unit vectors, they of fixed direction, they will have no derivative, and this is the strong positive point of this method. And therefore, as you have done earlier, you can very well recapitulate this, which we are not going to describe. Only thing, 2 points to be understood. How do we find out the direction of velocity and acceleration? It is simply tan theta is Vy by Vx or Ay by Ax. But if you go for three-dimensional cases, it will be a bit complicated. You will have to do it in terms of element L, M, and N, because their angular orientation specification requires three quantities element, of which two are only independent, and there is a relation connecting them. You know very well, and therefore, in that case, you can't just write tan theta. You have to write L is Vx by magnitude of V, or Vx square plus Vi square plus Vz square root. Another thing is trajectory of a particle in plane curvilinear motion is determined by eliminating t from x, t, and y, t. I think we will solve a few problems later on in this article, but what you have done mostly in your +2 classes, we will not repeat. That is, all those problems of projectile and things like that, which you have solved in large number. There is no point trying to repeat. The complicacy here in 3 dimension is not much. You will just have a Z term added to our BME. That is all. So we are not doing much of a discussion on this, as you are very much acquainted with the methods of rectangular coordinate. Is it okay? Is it clear? Let us go to the next topic, that is path coordinate. See, this you have done. What you have called as circular motion and centripetal acceleration, that is actually a simplified version of this topic. But all the expressions what you have studied earlier probably will be repeated, but their meanings will be extended to a sufficiently large extent. Now, why path coordinate? See, here we are using the path geometry of the path as coordinates. That is why we say path coordinate. Why natural coordinate? See, the velocity expression that we have discussed earlier, that is velocity is ds dt speed into epsilon t. Well, this will directly come out in path coordinates. Or what you have done earlier is nothing but indirectly, without telling path coordinate, we have used path coordinate. We also called it intrinsic coordinate. Why intrinsic? See, probably you may not know this. In differential calculus, in the chapter on curvature, we have a section called intrinsic equation of a curve. Here, when we use path coordinate, it means directly or indirectly, we are writing the trajectory, not in terms of x and y that you have been discussing just before in rectangular coordinates, but we are writing the trajectory or path in terms of intrinsic equation. What are these intrinsic coordinates? We will describe in the next slide or in the next page. The added simplicity here is, see, all expressions will be simple. That is why it's called natural coordinate, and they will have physical interpretation in its directly used form. Well, you will see when we discuss polar coordinate in our next discussion, expressions are complicated. They are no longer dependent on the path. They are no longer natural descriptions. So more natural a description, more simple is it, and more easier is it to interpret it physically. Well, but one point of caution, which is not for present discussion, the expressions that we deduce here for plane curvilinear motion will be identical with the expressions for space curvilinear motion, but there things will get complicated. See, here we will be describing the whole motion in terms of the tangent to the curve and the normal to the curve. But in space coordinates, tangent is a unique thing and normal is an unique thing. In plane motion or plane curvilinear, in space curvilinear motion, they are no longer unique things. We will have two more such. You will have two more such normals. One is principal normal, the other is binormal. And so far planes are considered in plane curvilinear motion, there is only one single plane, but here in space curvilinear motion there will be three planes: osculating plane, normal plane, and rectifying plane. And this osculating plane is the plane of motion. Just as from rectilinear motion, when you go to plane curvilinear motion, you see the direction of the particle or direction of motion of the particle or the velocity of particle is continuously changing. See, but in plane curvilinear motion, the whole motion is restricted to a single plane, the fixed plane. Whereas if you go to space motion using such path coordinates, what you will see, the analog of this constant plane will be a varying plane called osculating plane. And as time flows instantaneously, the osculating plane will start changing position. This will make the description of the motion more complicated. But so nice is the thing, the whole description and deductions hold even for 3D. Only thing is, here what you do as fixed plane concept, there you will have to just say, my plane is not a fixed plane, it is the osculating plane. This is given in differential geometry. This div geometry doesn't mean different, it is differential. Well, partly for shortening and partly for purposively that student go through lectures, we have written it as div geometry. It is not different geometry, it is differential geometry. So if you study differential geometry of curves in space, you will come to know of these concepts. And that is why, in spite of all the expressions being identical, it will be more complicated and problem solutions will become much complicated. We will restrict to plane curvilinear motion only. Okay? So let us go to the next slide, the deduction of the terms of velocity and acceleration, of which velocity you know very well because it is natural coordinate. But before doing anything, see what you said, r is equal to xi plus yj, position relation. If you differentiate position, you get velocity. If you differentiate velocity, you get acceleration. That is the logical and rigorous way of doing it. Now, we want velocity acceleration. See, x and y when differentiated gave you velocity and acceleration in x and y direction, vx, vy, ax, ay. What are the coordinates here? They are the intrinsic coordinates which is studied in differential calculus. Have you studied these in differential calculus? I think you should have. অঙ্কে করেছো differential calculus এ? Have you done it in differential calculus?
হ্যাঁ স্যার, এটা ওই কেটা ওগুলো
কার্ভেচারের চ্যাপ্টারটা পড়েছো? Have you read curvature?
স্যার আমাদের স্যার 6 দিনে পুরো সিলেবাস শেষ করেছিল, তো স্যার অত ভালো পড়ায়নি আমাদের অ্যাকচুয়ালি। মানে ডিফারেনশিয়াল ক্যালকুলাস আমাদের পড়ায়নি ঠিক করে একদম।
না স্যার কার্ভেচার আমাদের বাদ দিয়ে দেওয়া হয়েছিল ফার্স্ট ইয়ার থেকে। কার্ভেচার পড়ানো
ঠিক কার্ভেচার পড়ানো হলেও আমাকে বলতে হবে অ্যাজ রিক্যাপিচুলেশন, আর
স্যার
না হলে একটু লার্জার রিক্যাপিচুলেশন। So see, this is the curve, right? This is the curve, right? Now if that be the curve, এইটা curve দেখতে পাচ্ছ তো, এই পয়েন্ট থেকে আরম্ভ হচ্ছে, it is going towards there. So it is a curve, there is no motion. Don't think of any motion. Motion means any particle moves on the curve. We are only in differential calculus now. See, take this point, right? See, this is the tangent, right? Now if that be the tangent, the distance OA is called S, okay? And this angle of the tangent or the slope of the tangent is psi. See, if you specify S and psi, what do we mean by coordinates? If you specify coordinates, you get the position. X and Y specified, you know where the point is. We are not in motion, we are in geometry. You specify X and Y, we can tell you where the point is. Specify S and psi, we can tell you where the point is. You may say, well, S and psi is specified. Does it mean the point is specified? Yes. If you specify S and psi for all conditions, you get the total path. So this is called path coordinate. See, you are going along the path. The coordinate is going along the path. That is why it is called path coordinate. That is why it is called intrinsic coordinate. Now, the position of A is given by S and psi. What is the position of B? It is given by S plus S dash and psi plus psi dash. Very clear? Is this okay? And we know very well that, I should not say, you know this very well, not this. If you study the curvature chapter. This kappa is curvature, d psi ds. How fast is the tangent turning? How quickly is the tangent turning? That doesn't mean you are having motion. It is just differential calculus of curves, geometry. How quick is the tangent changing direction? That is measured in terms of that kappa or curvature. But you can approach the whole thing from trigonometry. You can write ds is rho d psi. Have you not read ds is r d theta in earlier? That is exactly what is we are doing. Probably in circular case you have written ds is r d theta and you wrote it very nicely. It is that same thing in generalized form. ds is rho d psi. And this you have done very well. Probably in your plus two, not even in plus two, in 9 and 10 you have done this. See, you will see one is the inverse of the other. Now we are going to a rigorous description. Here, curvature is d psi ds, or radius of curvature is ds d psi. Don't put much effort in learning this formula by heart. You know ds is r d theta. Instead of r you write rho, instead of theta you write psi. Why we are writing rho? There are implication is radius is something like constant radiation, therefore circle. You think this way. We are not thinking in this way. It is a general variable thing. See, the whole differential calculus of the curve, which is given in curvature, is intuitively understood by you earlier. But let us now put it in more generalized terms. Is it okay? Now, what do we see? This we need not explain any further. We have done it. Why we have done it? See, the path coordinate is so natural that in defining velocity, it has been directly or indirectly been used, and we have done this earlier. Now, we have to differentiate velocity and get acceleration. To differentiate velocity and get acceleration, what have we to do? We have to differentiate v a scalar and we have to differentiate epsilon t a unit vector. See, we have done it earlier. We are not going to draw any further pictures. Most books in mechanics do it repeatedly. We have done it once for all. See, what is epsilon t? When you differentiate with respect to time, just look into your previous formula. The previous formula in E, look into page E7. Instead of d epsilon dt, instead of d epsilon dt, write n d theta dt, n omega. N d theta dt, instead of d theta dt, it is d psi dt. And what is n? N is in the direction of omega, or increasing theta or increasing psi, a unit vector 90 degree away. So what do we get? See here, this is the direction of the tangent. This is the direction of increasing psi. So this is the direction of rotation or direction of increase of psi. Go 90 degree ahead. It is this. Is it not the normal direction? So what we have concluded that derivative of epsilon t with time will be this. Please be sure you have understood this. If you have not understood this, then there is no reason as to why you will not understand. Then you will face problems. Just now, give me your problems if you have, because we will use this repeatedly. Any problems? If you have any problems, please mention. Should we proceed?
Sir.
Is this recollect thing clear to you?
No, sir, the recollect thing is kind problematic.
Problematic. Have you
Sir, I
studied?
cannot understand.
Actually, sir, we didn't do this earlier.
But I have
ছোট প্রবলেম
discussed
হচ্ছে
in T7P. In T7P, have you studied it? Have you
Yes,
studied
sir.
T7P in our last discussion?
Yes, sir.
Then open T7P. You have got the notes. In which portion are you not able to understand? That is why I told you additional contact hours is required. People come to class unprepared. Have you opened T7P? In your parallel section, Professor DN has not at all discussed this. He has done it very quickly. Where is the problem? Have you studied T7P? There is no answer. See, it will be non-contact class. Students will not study and come. This
Yes,
is the
sir.
problem. Where is the problem in T7P? I will not
So that
entertain here further. Please understand, I will not entertain such problems if you have not studied. We will not refer back to previous lectures or discussion for the purpose. But just because it is the first time, I will entertain. But in general cases, it will not be entertained, and slowly it will be a problem. Where is, point out where in T7P you have problem when we use it. You are simply idly saying, I have not understood. There is a problem. Where is the problem?
sir, in T7 there was no problem, but here is a problem because there the angle was measured from the point from where we are taking the r vector, but here the vector is the tangential vector which makes the angle with x-axis. So those are different, I think.
Are you in your senses? তুমি কি সেন্সের কথা বলছো?
আচ্ছা,
Have you
বাংলা
not
বলবো?
gone mad? You are virtually going mad. See, this is a deduction. The deduction of the result is d epsilon dt. See, d epsilon du is n d theta du. Instead of you put t, what do you get? N d theta dt. Here, what will you get? N d psi. What is d psi dt? Psi dot. What is n? Clockwise unit vector. What is counterclockwise unit vector? Epsilon t. It is epsilon n. Where is the problem?
Okay, sir, no
When
problem, I
you
got it.
use a formula a plus b whole square, do you prove it? This is the proof and this is the result. Last line is the result which we are employing. এ তো তোমার মানে বেসিক এর প্রবলেম, মানে স্কুলের অ্যালজেব্রা করোনি, ফর্মুলা ইউজ করে সেই ফর্মুলাটা কি আবার ইউজ করো? a plus b
হ্যাঁ
হোল
স্যার, বুঝতে পেরেছি।
সেইটাকে কি তুমি প্রত্যেকটা অঙ্কে আবার প্রমাণ করো? তোমার তো তাই কোয়েশ্চেন দাঁড়াচ্ছে।
হ্যাঁ স্যার, বুঝতে পেরেছি।
না বুঝতে পারোনি, আমি পরিষ্কার বলে দিচ্ছি তুমি পড়োনি এর আগের দিন। See, this is a general discussion I make. See, those who do not understand, but possibly I told you any problems here because I was trying to trap students who do not study. They will get caught here. Please do not ask questions you have not studied earlier. The course will be difficult for you. I can't help. Because if you think by remaining idle, you will be understanding things. Even in a physical class, we do not entertain. It is very difficult because time gets wasted like anything. See, the derivative here is simple. dv dt into d epsilon t dt. Rest is simple algebra. There is no reason as to why we should go on speaking of these terms. It is simple algebra, nothing. ABC of algebra is there and little bit of calculus. But please remember one thing. You have studied these formulas v square by r, omega square r, v omega. Right? You call this centripetal acceleration. No, we will now call it normal acceleration, and instead of writing v square by r, we are saying simply v square by rho. Instead of omega square r, we are calling psi dot square rho. Or if you want to express the intrinsic coordinate not as psi, you can put theta also. There is nothing wrong. Probably in Merriam it is written as theta. I have taken from some other book because there the descriptions are more rigorous. And instead of v omega, we are writing v psi dot. The same formula, you have nothing. No, your brain will not get taxed with new formulas. Only thing, the implication will be different. You will see when we start solving problems. And then what we call is dvdt is tangential acceleration, and this quantity is called normal acceleration, what you call centripetal acceleration, and they are shown in the figure here as at and an. Can we move to the next discussion? See, rather, let us be a bit cautious. The two things they have see, I had been a bit, there is a bit of mistake. Open T15. If you have the notes, T15 should come first, then T14. They have been somehow put wrong in the schedule. No, let's see, is this better? T15? Is this when T14? No, it is better to discuss T15 first. T14, T15 will be better than T14. Because this we will do right at the end, after T15. See, this is a physical understanding and geometrical interpretation of this. So long what we have done is we have done mathematics. We have used simple vector calculus. See, the particle moves from here to here. We will not do anything. We will go for a graphical or geometrical understanding, which will give us a physical description and interpretation of our terms. See, we are putting these two in a velocity polygon outside or velocity triangle outside. So we are plotting from the a single pole V, V plus delta V. This is a velocity diagram. And therefore, this red quantity is delta V. So let us resolve delta V into two directions. Along V, which is the tangential direction. This is the tangential direction, which is along V, and perpendicular to V. Now, if delta psi is small, that means this is small. That means these points are close to each other. Well, we can say the component which is perpendicular to V will be almost coincident with the secant here. With the secant here. That is, what is the secant? If we take V and we put a circle with this as the center, we will get a curve. So with this curve, which starts at the V line, ends at the V plus delta V line at some other point. What we do is we join these 2 points. The statement made is if delta psi is small, well, this secant to this curve, or rather to the circle with this V magnitude as radius, will be same as the perpendicular to V, because delta psi is small. So indirectly, physically, we are going to the limiting process. Now, this component is along V and therefore is in the tangential direction. This is perpendicular to V and therefore is in the normal direction. Now, see, if we take the tangential direction, what we see? See, this perpendicular meets this V plus delta V line at almost the same point for small delta psi as a circle. Now, if the circle here has radius V magnitude, here it is V magnitude. So what is the additional length here? The additional length is the increase of length of the velocity vector, and therefore increase of length of velocity vector means it is the magnitude increase of velocity vector, and therefore it is speed. And when we go to delta t tending to 0, what we see, these two are almost in the same direction, and therefore the tangential component of velocity change, tangential component of velocity change reflects the change in magnitude of velocity, and therefore it is a measure of the rate of change of magnitude change. And that is why in the formula you have obtained that rate of change of speed is the magnitude of tangential acceleration. Go back to your previous discussion. What have you seen? dv dt into epsilon t term. Why are you getting dv dt? See, this dv dt is rate of change of speed. So what does tangential acceleration show? It shows the increase of magnitude of velocity. That is why it is appearing as dvdt. Whereas if you go to the normal component, what do you see? The component swings. What does it do? It takes care of change in direction of v. Now, how do you say what is delta v? Well, it is r delta theta. So v magnitude into delta psi. Go to the limiting process. What do you get? V psi dot. The formula matches. The formulas match. Why? Because the physical implication that normal acceleration takes care of direction change of velocity, the tangential acceleration takes care of magnitude change of velocity, is the root cause as to why these two descriptions match. This is the physical way or the geometrical way of understanding, and what you have done in the previous slide, that is T13, is the mathematical way of doing it. The two descriptions match, and to make the description more vivid, we have put this here. If you have any problems here, you can raise, because you may feel some confusions, but it is not much complicated. যদি কিছু বলার থাকে এইখানেই বলো. Ask just now. Do not ask in the next class. কিছু আছে? তো বল. The crux of the whole thing is normal acceleration takes care of direction change of velocity, tangential acceleration takes care of magnitude change of velocity. So change of speed is reflected in tangential acceleration. Is this okay?
Yes, sir.
কি জিজ্ঞেস করবে তো করতে পারো এখন. Any queries?
No, sir.
Okay, 14. Now see, in Miriam, the discussion has been more simplified, but why we have done it? To maintain the strict way how mathematicians do it. See, what we say does not matter what motion is. Let us put correct conventions to TNN. The way we mention, we are describing T as it is in the direction of increasing S. So it has nothing to do for a particle. See, even for a differential geometry of the curve, if S increases, we say in that direction T is positive. Right? So if X increase, in that direction we take I positive. If Y increase, we take that direction Y positive. Now, how do you define positive N? 90-degree counterclockwise with respect to positive T. And how is psi measured? From positive X to positive T. See, everything is clear in our previous diagram. But now, make it clear here. If this be the curve, psi is, this is positive T and positive N. দেখো আমরা যা বলেছি positive T and positive N. It should be clear. Positive T increasing direction of S and positive N counterclockwise with respect to it. In all of these cases, they are true. I think you should not get confused out positive T and positive N. Right? Now, only thing to be understood, in two of the cases, rho is positive, two of the cases, rho is negative. Why? What is rho? ds d psi. If S increases, when psi increases, rho will be positive. That is what you have done in your earlier understanding of calculus in class 2. Here, if you go from this to this direction, S increases. Okay? If S increases, do you see psi increases? Yes, psi increases. So rho is positive. But here, if S increases, you see tangent becoming flatter. So psi decreases. Rho is negative. Here, as S increases, we will see that psi decreases. See, it becomes less steep. Psi decreases. Rho is negative. Here, as S increases, I also increases. Rho is positive. Is this okay? বুঝতে পেরেছো?
স্যার মানে
বলো।
ইয়ে নর্মাল যে এনটা স্যার ডিরেকশনটা স্যার আরেকবার একটু বুঝাতে ভালো হতো।
এন এর ডাইরেকশনটা কি দেখো লেখাই আছে তো 90 ডিগ্রি, ওই জন্য বারবার বলেছিলাম যারা ক্লাস অ্যাটেন্ড করবে এর আগের দিন দেখে এসো। তোমাদের বুক তো যে সিআর সে বলেছিল we will first do class and then we will study. It will take more time, less understanding. See, everything is written here. 90 degree counterclockwise with respect to positive t. So if it is positive t, what is positive t in the increase?
ওকে স্যার বুঝে গেছি স্যার বুঝে গেছি।
তাহলে একটু দেখলে কত সুবিধা হয়।
হ্যাঁ স্যার আগের লাইনটা স্যার অ্যাকচুয়ালি মিস করে গেছিলাম স্যার। ওকে স্যার
ঠিক আছে, নো প্রবলেম, নো প্রবলেম। এইটা যদি বুঝতে পারো কোনো অসুবিধা হবে না। বাট ওয়ান মোর থিং টু বি আন্ডারস্টুড, ফ্রম 1 to 2 rho changes sign. When rho changes sign, we say there is a point of inflection. What happens at the point of inflection? At the point of inflection, rho changes sign. Rho will become 0. So curvature will become infinity. Curvature will become infinity. Same thing, rho changes sign from positive to negative here, from negative to positive here. Is it okay? Now, what about mechanics? If speed increases along plus t direction, now how do you get plus t direction? Along increase of s. See, you must know from calculus or geometry. Let us move to mechanics. How do you fix plus t direction? It is the direction in which s increases. In mechanics, in which direction does s increase? In the direction in which the particle moves. So, if you see that speed of the particle is increasing in the positive direction of t, we call at as positive. So, if speed increases along plus t, then we say at is positive. এটা বুঝতে পেরেছো? না বুঝলে এক্ষুনি বলো। Because it is infinity, right?
Yes sir.
Speed increases in positive t, along positive t. If speed increases, what is positive t? Increase of s. So as s increases, speed increases. So as s increases, if speed increases, we will say it is positive. N is positive towards center. See, you will clearly see v square by rho is n. So rho is positive, v square is necessarily positive. So n is in the positive n direction. V square by rho is negative. V square is positive, so it is in the negative n direction. Here, V square is positive, rho is negative, so it is in the negative n direction. V square is positive, rho is positive, in the positive n direction. Is it clear? Now, you may see little bit of contradiction with, probably not contradiction, you will see in Merriam's book, they have not given this positive n this way. This is the way people of mathematics or differential calculus do it. That is why we have tackled it this way. Merriam does not do it this way. In other texts, I don't know what they have done. They may do similarly. In Merriam, they clearly say, see, the direction in which the center of the curve lies. See, this is concave this way. So n is here. Merriam clearly says n is here. If they put n in this direction, you will see. They will put n in this direction so that n is always positive in the plus n direction. But people in calculus do not do it this way. They put proper directions to n and then they say whether n is positive or negative in the positive n direction or negative n direction. But always remember, with your previous idea of centripetal acceleration, the acceleration in the normal direction, what you called in simplified form as centripetal acceleration, it will be directed towards center. And that is why quickly you can remember, this will be in this direction, this will be in this direction, this will be this, and this will be the direction of n. Is it clear? এইখানটা confusion করো না. This is being more rigorous or methodical. We have given you this. If you want to know the name of the book where you can find, you can get any book
Yes.
on differential calculus, or you can get mechanics, introduction to mechanics by Quarding and Ramsey. এই বইটা হয়তো পাবে না। A more rigorous treatment we have done. Okay?
স্যার বই টিমোশেঙ্কোতে পাওয়া যাবে স্যার?
হ্যাঁ,
মানে টিমোশেঙ্কোর বই টিমোশেঙ্কোতে
না,
পাওয়া
মনে
যাবে?
হয় না আছে, মনে হয় না আছে,
ওকে স্যার।
মনে হয় না আছে।
হ্যাঁ,
আমি এক্স্যাক্টলি বলতে পারছি না, আমি টিমোশেঙ্কোটা এক্ষুনি কি করে ডিডিউস করেছে মনে নেই, মনে হয় না, প্রবাবলি নো, প্রবাবলি আমি ঠিক বলতে পারছি না,
ওকে স্যার।
আমি দেখিনি, আই হ্যাভ নট সিন। ইজ ইট ওকে?
ইয়েস স্যার।
So this is the simplification of it. See, which you have already done in +2. See, your circular motion, that is a very much special case of this path coordinate or intrinsic coordinate or anti-coordinate, whatever you say. Only thing what you have used by omega, which I had already given caution to you in this regard. Omega should never be studied in particle motion. What is meant is omega should always connect itself with a line. In circular motion of particles which are studied in +2, that line which they were somehow calling was the radius or the connection between the center of the circular motion and the particle position, which is not really a rigorous description. So that is why we have given question mark angular velocity in circular motion. We should not call it really angular velocity. Angular velocity has a very different meaning in mechanics, which we will slowly discuss when we go to rigid body motion. Okay? Right? Should we proceed later or 55 minutes or approximately 1 hour? Should we go to r theta or next class we will do it?
স্যার বলছি যে ওই মানে এই যে টপিকটা কভার করলেন এটার উপর মানে কোন সাম যদি একটা এক্সাম্পল।
হ্যাঁ, সাম তো করতে হবে, কিন্তু মুশকিল তো আমাকে ট্রান্সমিট করতে হবে সাম, এরপর আমি r থিটাটা করে দেব। r থিটাটা করব। আর টুডে ইজ ওয়েডনেসডে, রাইট?
হ্যাঁ স্যার, কালকে ক্লাস আছে।
কালকে থার্সডে আমরা ক্লাস করব। আমরা r থিটা করে we will give you প্রবলেমসটা দেখা যাক কি করে দিতে পারি। হতে পারে সেটা ছবি তুলে দেবো, মানে যদি মেরিয়াম ক্রেগ 7th এডিশন নেই তাহলে প্রবলেমটা দেখিয়ে, কিন্তু সলিউশনটা তো তোমরা আর ওরকম ভাবে পারবে না, কারণ সলিউশনটা আমি যেখানে দেখাবো কি করে, ও মোবাইল দিয়ে তোমরা কিছু দেখতে পাবে না। বা আমি দেখছি প্রবলেমটা স্ক্যান করে পাঠিয়ে দেবো, তলায় তলায় সলিউশনটাও স্ক্যান করে দেবো, দেখে এলে দেন উই ক্যান ডিসকাস। আদারওয়াইজ এখানে আমি পেনটা দিয়ে অঙ্ক কষা খুব মুশকিল হবে।
হ্যাঁ স্যার, মানে স্যার আপনি তাহলে প্রেজেন্ট করুন তাহলে মানে অঙ্কটা,
তাই ইনডাইরেক্টলি এইখানে হোয়াটসঅ্যাপে দিয়ে দেবো বা অঙ্ক করবো, especially on path coordinates and polar coordinates. We have to solve a large number of problems.
Exactly.
And that we'll do at least 10-12টা তো করতেই হবে। রেক্টিলিনিয়ার মোশন আর রেক্ট্যাঙ্গুলার ট্র্যাজেক্টরি অফ প্রজেক্টাইল, ওইগুলোতে একটা কি দুটো অঙ্ক করেছে।
ওকে,
তাহলে আমরা নেক্সট ক্লাস হবে বৃহস্পতিবার। তোমরা কি নাও ইউ সে, আমি কিচ্ছু বলবো না। আমরা তাহলে থার্সডে হলে আমরা 3 পিরিয়ড হয়ে গেল, তাই তো?
হ্যাঁ স্যার।
কি 4 পিরিয়ডে রেস্ট্রিক্ট করতে চাও না শনি রবি 2 দিন করবে?
স্যার 4 দিন ক্লাস করলে তো স্যার আই থিংক মানে 4 দিন ক্লাস করলে তো অসুবিধা তো কারোর হওয়া উচিত না, কারণ এমনিতেই
তোমাদের 3 আওয়ার্স পার উইক আছে, এটা 4 আওয়ার্স পার উইক। আর যদি বলো 5 আওয়ার্স করতে চাও তাও করতে পারো, আমার কোনো আপত্তি নেই। তোমরা বলো।
আপনি 5 আওয়ার্স এমনিতে প্রথমে ইয়াশকে বলেছিলেন আমাদের সিআর কে যে 5 ডেজ আ উইক, তো এবার স্যার ওটা থেকে আপনি যদি 4 দিন করছেন তাহলে তো স্যার আমাদের তো সুবিধাই হচ্ছে, মানে কম হচ্ছে।
আমি করছি না, তোমরা যা বলবে করব।
মানে অ্যাকচুয়ালি স্যার আপনি মানডে আর ফ্রাইডেটা স্যার বলছেন যে আপনাকে ইউনিভার্সিটি যেতে হয়, আর আমাদের থার্সডে
যদি সেরকম দরকার আমি একদিন তুলে নিতে পারি না তা নয়, তবে টিউসডে ওয়েডনেসডে টিউসডে তোমাদের অসুবিধা আছে, ওয়েডনেসডে, থার্সডে এন্ড স্যাটারডে সানডে করতে পারি।
হ্যাঁ স্যার করুন স্যার, অসুবিধা নেই, আমার অসুবিধা নেই, বাকিদের কারোর কোনো অসুবিধা হলে ওরা করতে পারে।
আমরা স্যাটারডে তো নেক্সট আমরা কালকে তো করছি,
হ্যাঁ স্যার।
ফ্রাইডেটা ছেড়ে দাও, স্যাটারডে ফ্রাইডেটা অতটা করে দরকার নেই, স্যাটারডে করবো তাহলে।
ওকে স্যার।
ওকে,
ওকে
is
স্যার।
it okay for you?
Yes sir.
Any student who now wants to ask question, he is free to ask, but do not start asking questions which will not be possible to be answered in the next class. আমি ওই ক্লাসের ওইটা বুঝি না, মুশকিল আছে। তাহলে শুড উই স্টপ রেকর্ডিং, না কেউ কোয়েশ্চেন কি করছো করো সেটা রেকর্ড করে রাখতে চাও ইফ এনি? বলো বলো, শুড উই স্টপ রেকর্ডিং?
ইয়েস স্যার, স্টপ করে দিন তাহলে, কেউ যখন কিছু